Hello, everyone. Welcome to A1 Tutor Live class, another session for mathematics. All right, so we're going to be having a new topic today. Last week we treated, or this week we treated fraction, percentage, and decimal. And we've completed that topic. And today we are looking at a new topic, which is indices, logarithm, and surds. So we are looking at the new topic, indices, logarithm, and surd. So that's the topic we are looking at today. We'll be discussing this topic today. And to make it more easier for us to comprehend, we are going to have this topic for two classes. So for today, we'll focus on indices. For today, we are going to focus on indices. All right, we're going to focus on indices for today's class. Okay, but before we commence, I want to be sure that everyone can hear me perfectly, and as well, we can see what I have on the screen. I want to be sure. So write in the chat box, just give a thumbs up or send an emoji to signify that you can hear me properly. All right. Okay, so good. So let's proceed now. We are talking about indices today. We'll be discussing about indices, and which is a topic we've been doing from, let me say, from primary class. Yes, right? All the way from primary class, primary 4, primary 5. We have been doing indices up to GSS level, still in SS level. Okay. Now, what do we call indices? When you hear the word indices, what comes to your mind? If you are very conversant with what you've done in your previous classes, probably primary class or GSS, there's something we call indexed. We can express a number in index form. For example, if I have 2 multiplied by 2 multiplied by 2, if I want to write this as an ordinary number, that will be 8. That's an ordinary number. But if I want to write it in an indexed form, that is, I will express that number in the way it's going to have an exponent. What I mean by an exponent is power. Exponent, I mean power. So I'm going to express the number in a way that is going to have a power. So this 2 times 2 times 2, which is 8, can also be written as 2 raised to the power of 3. Raised to the power of 3. So this is called an indexed form. This is called an indexed form. And this is the basic foundation of the topic indices. Is the basic foundation of the topic indices. Now, if I ask the question, how did I get these 3? Some believe that you just count probably 1, 2, 3, and that's why you have 3 here. Yes, it's acceptable in that way also, but it is because 2 has an invisible power, which is 1. This also has an invisible power, which is 1. And this also has an invisible power, which is what? 1. So the law of indices comes in by adding the first power plus the second power plus the third power. Then we have 3. So it will be in this way: 2 raised to power 1 plus 1 plus 1, which is 2 raised to power 3. So the expression of a number in this form is called an indexed form, and that leads us to the topic indices. It leads us to the topic indices. So what we expected to do in indices is that we'll be given question, numbers will be expressed in indexed form, and will be asked to simplify. Equation will be expressed in indexed form, and will be asked to find the value of the variable in that equation. So mostly we'll be working with number expressed in indexed form. That is, the number will always have a power, a power. So this is the basic foundation of indices. All right. So before we kickstart, I want to have a warm up with us. So I want us to follow me. Let's consider this question. 2 raised to the power of 1 over 2 times 2 times 1 over 3 times 3 times 1 over 4 times 4 times 1 over 5 times 5. All right, a warm-up session for us. Quickly, I want someone to tell me what will be the final answer of this expression. 2 raised to the power of 1 over 2 times 2 times 1 over 3 times 3 times 1 over 4 times 4 times 1 over 5 times 5. What will be the final answer? The final answer of this expression. Okay, I'll be waiting for a response in the chat box. Yes, it's a very simple question. It's just technical. So I want to be sure that some of us can solve this. I'm waiting. 2 raised to the power of all this we have here. What will be the final answer? Waiting. We just need to simplify this and we have the final answer. I'm still waiting. I'm still waiting. Let me have your response in the chat box. Just type your response. You can give it a try. Give it a try. Still waiting. 1. All right. Can I have one more response? 2. All right. Okay, good. Great responses. Yeah, that's a great response for both response. Okay, now let's look at how we solve this question and what is going to end up to be the answer. All right. Okay, let's do it together. Let's join in together to solve this question. Now we have all these, they serve as exponents. That is, they are all power. They are all power. Okay. So what do? We need to simplify the power first. And of course, 1 over 2 multiplied by 2, 2 here cancel 2. All right. And the same thing here, 1 over 3 multiplied by 3, 3 here cancel 3. All right. And also 4 cancel 4 and 5 cancel 5. If you notice, you will see that we just have 1 times 1 times 1 times 1 times 1 up to the last one. So we have 2 raised to power. If I multiply 1 times 1 times 1 times 1 is also 2 raised to power 1. And 2 raised to the power of 1 is also 2. So the response is 2. The response is 2. All right. So that's just a warm-up that will lead us to the laws of indices. The laws of indices. If you understand the law of indices, you'll be able to lay your hands on any question that has to do with indices. No matter how magnificent the question can be, you will definitely solve it if you understand the law of indices. All right. So, okay, let's proceed. So we want to observe each of those laws, one after the other, the laws of indices. If you are with me, I would like to clean the board so we can proceed. I believe I can do that. I can rub off the board now. So we move to the next thing. I need a reaction for that. Can I clean the board? You can just type yes. Waiting. Can I clean the board? I believe what we have here, what we have just solved, this warm-up question is clear to everyone. So we want to continue with the laws of indices that we have, the laws of indices. So if you are okay with this, if it's clear to you, just type yes so we can proceed. Waiting. Just type yes in the chat box and we'll proceed. If this warm-up question is clear to you, just type yes so we can proceed to the laws of indices. All right, okay. So let's proceed to the law of indices. I'll be wiping up the board now. The law of indices. The law of indices. The law of indices. The first law of indices is stated as we have on the screen. A raised to the power of x multiplied by a raised to the power of y will be equals to, take notes, let me explain this, that a raised to the power of n, let me use n this time around. A here represents the base. A is called the base, and this n is called the power. Is also known as the exponent or power. So for an index form, we have two components, which is the base and the power. The base and the power. Okay. So for us to make use of the law of indices, we must ensure that the base are the same. The base are the same. A is the base here. A is also the base here. So we have the same base, the same base. So when we have multiplication in between this kind of expression, the multiplication will change to the addition of the power. So we'll be adding up the power. We said A, pick one of the base since they are the same. A raised to power x plus y. That is multiplication change to the addition of the power. Multiplication change to the addition of the power. All right, let's take a simplification. Let's say I have 7 raised to power 2 multiplied by 7 raised to power 5. The base here is what? 7. All right, and we have multiplication that joins both of them. So we have just one of the base, we'll pick 7, and because it is multiplication, so it will change to addition of the power. So we'll be having 2 plus 5, and that will be 7 raised to power 7. 7 raised to power 7. All right, okay, let's take one more. I have x raised to power minus 3 multiplied by, all right, let me use y so we won't be confused. Y raised to power minus 3 times y raised to power minus 3. What will be the answer? Y raised to power minus 3 times y raised to power minus 3. I want response in the chat box. What will be the response? Still on the first law of indices. Yes. What will be the response for this? Y raised to power minus 3 multiplied by y raised to power minus 3. Following the rule, the first law of indices. First law of indices. I'm waiting. Do we have any response? Y raised to the power of y. Okay, any other response? Still waiting. Okay, All right, let's do it together. The base is y, all right, and the power is minus 3 minus 3. So we'll be having y raised to the power of minus 3 plus. Ensure that your plus is there because the multiplication sign will change to addition sign at the power space. So we have brackets because the second power here is negative. The second power here is negative. And I will always advise that you use brackets to avoid errors, okay? So minus 3 in the brackets. Then we have y raised to power minus 3 plus times minus. Plus times minus will give us minus. So we have plus times minus, we have minus, then 3, and that is y raised to the power of minus 6. Minus 3 minus 3 is minus 6. So the response will be y raised to the power of minus 6. Minus 6. All right. I believe we understood that. Now we move to the second law of indices. The second law of indices. I'll be cleaning the board now so we can proceed to the second law of indices. I want to be rest assured that the first law of indices is clear to everyone, right? Can I have a reaction? The first law of indices is clear with this simplification that we had under it. All right, okay. We'll move to the second law of indices. Number 2, the second law of indices. A raised to the power of x divided by a raised to the power of y equals to, now this is the second law we are considering now. When we divide an expression of this nature, where the base are the same, the law says that the division sign changes to minus at the exponents, changes to minus at the power, okay? So that will be a raised to the power of x minus y. A raised to the power of x minus y. Take note, this also can be expressed as a raised to the power x over a raised to the power y. Is still the same thing as a raised to the power x minus y. Because what we have here is called the line of division, so it's also standing as a division sign. It also changes to minus. It also changes to minus. All right. Now let's consider a simplification. I have, let's say we have 7, this time around, 7 raised to power 4 divided by 7 raised to power 1. And we want to simplify this. This will give us 7, which is the base, 4 minus 1, the power, 4 minus 1. And that will be 7 raised to power what? 3. 7 raised to power 3. Is that taken? Let's take one more. Y raised to power minus 4 divided by y raised to power minus 2. That will give us y minus 4. That's the first power. Division change to minus. All right. Then we have minus 2 here. Minus 2. So I will still advise that you put it in a bracket. So bracket minus 2. And to simplify, we have y minus 4. We need to multiply this because this bracket represents multiplication. Minus times minus. Minus times minus, that is plus. So we'll be having plus 2. Minus 4 plus 2 equals to minus 2. I believe you understand that. You are owing 4 naira. Let's assume it's money. Minus means you are owing someone, and in your pocket you have 2 naira which belongs to you. When you pay out, plus means that you are paying out the 2 naira out of the 4 naira you are owing. So if I pay 2 naira and I was owing 4 naira, right? After paying 2 naira, I'm still owing another 2 naira. That is why minus 4 plus 2 is minus 2. So this will give us y raised to power minus 2. Y raised to power minus 2. So this is the second law of indices. The second law of indices. Let's move on to the third law of indices. I'll be cleaning the board now. The third law of indices. Number 3. The third law of indices states that a raised to the power of 0 is equals to 1. A raised to the power of 0 is equals to 1. So we have the third law that states that a raised to the power of 0 is 1. That is, any variable, that is alphabet or number, raised to the power of 0, raised to the power of 0 is 1. Okay, so let's assume I have 30, open the bracket and close bracket, raised to the power 0. My answer will be what? 1. 30 raised to the power 0 is what? 1. What about if I have A, B, C, D, close bracket, raised to the power 0? What will be the response for this? Response for this? 1. Great. Great response, Emmanuel. 1. The response will be 1 because we stated that a raised to the power of 0 is 1. That is, either value like alphabets or numbers, if it is raised to the power of 0, it will be 1. If I said 1 million, 1 million raised to the power of 0, we also have 1. All right. Also, let's say we have George. Let me write a name now. Raised to power 0, it is also 1. That's the law of indices. It is also 1. Okay, so this is the third law of indices. A raised to the power of 0 will be equals to 1. Let's move on to the fourth law of indices. The fourth law of indices. I'll be cleaning the board now. So we'll take the fourth law. Number 4, a raised to power x, a raised to power, let's have it in this way, a raised to power minus x, a raised to power minus x will be equals to what? Law of indices. That will be 1 over a raised to power x. 1 over a raised to power x. That is, the minus we have here, this minus has changed to division. And that is why we have 1 over a raised to power x. 1 over a raised to power x. All right? So if I have something of this nature, y raised to power minus 4, if I want to write this, it's going to be 1 over. The minus sign has changed to division. Now take note, this x here can be any number. It can be 2, it can be 7, it can be a fraction, of course. It can be 1 over 2, it can be 0.5, it can be any value. Are you getting me? So that means any value that we have as x will be represented here also. We have it back here. So for this case, my x here is this 4. So I'll be having y, which is the base, raised to power what? 4. So y raised to power minus 4 is 1 over y raised to power 4. Y raised to power 4. If I have 10 raised to power minus 2, that will be 1 over the base is what? 10. And here we have what? 2. So it will be 1 over 10 raised to power 2. I believe you understand that. So this is the fourth law of indices. The fourth law of what? Indices. All right. So let's move on to the fifth law of indices. The fifth law of indices. So I'll be clearing the board so we can proceed to number 5. The fifth law of indices, a raised to power x, close bracket, raised to power y. A raised to power x, close the bracket, raised to power y will be a raised to power x times y. And that is a raised to power xy. That is, we are going to be multiplying the exponent or the power we have on a with the one we have on the brackets. Okay, so that is x times y. So let's say we have 4 raised to power 2, open and close the bracket, raised to power 3. This should give us 4. The power is 2 times what? 3, which is 4 raised to power 6. 4 raised to power 6. What about if I have y raised to power minus 2, all right? Open and close the bracket, raised to power 4. The same law again. We have y raised to power minus 2 times 4. That will be y raised to power minus 8. Y raised to power minus 8. And this also leads us to another rule or to another law of indices, and that can be 1 over y raised to power what? 8. You know, this was the fourth law of indices we treated. So I need to simplify more further to have 1 over y raised to power 8. So I believe we are following. So if this law, the fifth law of indices, is clear to you, thumbs up in the chat box. We are moving on to the sixth. All right. Thank you for your response. We are moving on to the sixth law of indices. So I'll be cleaning the board. Number 6, law of indices. All right. The sixth law of indices is we have a raised to the power of 1 over x. 1 over x. This will give us the square roots. We have x here, and we have a, which is the base in it. Now, how do we get this? This 1 over x is representing root. So it is the root of x. Or let me say the x root, because we have square root, we have cube root, we have fourth root, and we have the fifth root, and so on and so forth. So if I have 1 over 2 here as the power, it means I'm talking about the square root. If I have 1 over 3, I'm referring to the cube roots. If I'm having 1 over 4, I'm referring to the fourth root, and so on and so forth. So this power here represents the roots we are working with. So this is 1 over x. It represents the x roots, and that is why we have x here. And x can be any value. It can be any number. For this case, x is what? 2. For this case, x is what? 3. And for this case, x is what? 4. So we have a raised to power 1 over x is given as square root. Then you have x. That's the x square root of what? A. A is the base. A is what? The base. All right. So let's take one simplification on that. I have, let's use 16 raised to the power of 1 over 2. 1 over 2. If you are to solve this using this law of indices, 16 here represents A. We need to break it down, okay? Then 2 here represent what? X. So I have something of this nature. Draw my square roots. And inside the square root here, if we have X here, and I said here, my 2 represents X. That means I will have it 2 here. That's square root, of course. Then this is A, and my A here represents 16. That means I have 16 inside here. So it means the square root of what? 16. The square root of what? 16. And that will give me the square root of 16 will be what? 4. And the final answer is said to be what? 4. Same thing applicable if I have 64 raised to the power of 1 over 3. It means I'm working with the cube roots. Take note, here we have x to be 3. Cube root of what? 64. And the cube root of 64, the cube root of 64 will be what? 4. That is a number you multiply by itself 3 times to get 64. And that is 4 times 4 times 4. That will give us 64. So the cube root is what? 4. The cube root of 64 is what? 4. So this is the sixth root, the sixth law of indices. Number 6 law of what? Indices. We are going to take the last one, which is number 7. Then we are going to take some applications of all these laws we've discussed earlier. Okay, so I believe we are together. Let's move on to the 7th law. The 7th law of indices. The 7th law of indices. I believe this is clear. Can we move on with the 7th law? Is the 6th law of indices clear to us? All right. Okay. Okay, I'll do one more simplification for this. We need to do one more for someone to understand. All right. So let's pick one more question on that. Okay, so let's consider this question this time around. We have 8 raised to power 1 over 3. All right. I believe Enoch is following us. So we want to simplify this using this law. Now, what you need to do is to compare. So you know how the law is working. We said a raised to power 1 over x is the square root of a, and we have x here. Now, let's identify a in this expression. This 8 here serve as what? A. Do you agree with me? Okay. This x here serve as what? 3. So that is my x here is what? 3. Now let me just write the same thing I have here, square root. I'm supposed to put x here, but my x is now representing what? 3, right? So that means I will not have x here again, but I'm going to have what? 3. And this represents a. And for this question, my a is what? 8. My a represents what? 8. That means inside the cube root, I'm going to have 8. The reason why we call this cube root is because we have 3. So if it is 2, it will be square root. If it is 4, it will be fourth root. If it is 5, it will be what? The fifth root. Are you getting that? Now, we want to find the cube root of this. Assume you don't have a calculator and you want to do this. What we have to get is a number that will multiply itself in 3 places and give you 8. What is that number? Let's think together. If I use 2 times 2 times 2, 2 times 2 is 4, times 2 is what? 8. So that means 2 is the number we are talking about. If I multiply 2 by itself 3 times, I'm going to get 8, which implies that 2 is the cube root of what? Of 8. 2 is the cube root of what? 8. So we have it as the answer to be what? 2. And if you don't want to use this approach, I can also solve it in this way. I will say 8 raised to power 1 over 3 is also expressed as this 2. Let me present 2 as an indexed form. Okay? 2, this 8 rather, let me present 8 as an indexed form. 8 also is the same thing as 2 raised to the power of 3. Do you agree with me? Because 2 raised to the power 3 will give me 8. I will open the bracket and close the bracket. Now I will put this power outside the bracket. What I have in the bracket is still 8, because if you multiply this, you end up to have 8 as your answer. So with this, I can say 3 cancel 3. I'm having 2 raised to power 1 left, and which is also 2. So we have 2 as the answer. I believe, Enoch, this is clear now. So we can proceed to the next. Enoch, I believe it's not clear to you. All right, thank you. Thank you for your response. Okay, so let's proceed to the next law, which is the last law of indices. I will clean the board. That is 7. A raised to power x over y. X over y. Now we have combination of two things. We have combination of that should be the law number 5, if I'm not wrong, and law number 6 together. We have them as one. So what do we do here? You just need to simplify. A raised to power x, okay, times 1 over y. A raised to power x times 1 over y. Because if I multiply x times 1 over y, I'll be having x over y. So I just splitted the power so that when I'm explaining, you get what we are doing. So what will this give us? If this represents, we are talking about roots, and in this case now we are talking about roots what? Y, not x. And this is talking about square, maybe raised to the power of a particular number. Are you getting it? So I have to consider this first. This is talking about roots. That is, I'll have a root first. And it's talking about what root? Y. We don't know what root exactly. We just have a letter, they're not a number. So this is Y. I'll have Y here. Okay. So the base is 8. The base is A, letter A. Letter A. The base will be inside the roots. Okay. Now, what is the last thing to do? I'll put a bracket. A bracket. Now, this x will now serve as the what? The power outside here. So this will be the result of a raised to power x over y. Let's do that with some numbers. Okay. I will have, let's say we have 16 raised to the power of, okay, let me use 64 so I can include 64 raised to power 2 over 3. 2 over 3. We want to simplify this. So we have for this, if I split this, I'll have 64 raised to power 2 times 1 over 3. All right. So this 1 over 3 is talking about the cube roots. Talking about what? The cube root. So I will have a cube root drawn. Then the base is 64. Base is 64, which is that A we have here. So write 64 inside here. Okay. Brackets open and bracket close. Then these 2 will serve as what? Your power. Raised to power what? 2. That's what we have here. We said we have y here. We have what? X here. Okay. So your denominator here will always be the root, and your numerator will always be your what? Your power. Is that taken? So let's simplify this. We are looking for the cube root of 64, a number that can multiply itself 3 times to give us 64, that will be what? 4. 4 times 4 times 4, that is 16 times 4, that is 64. So the cube root is what? 4. We have 4. I've just solved this alone. I've not touched the square here. So we still need to consider this square. So we now have the square on it. What we have inside the brackets gave us 4. Now we have the square on it. That will be 4 square, law of indices. 4 square is the same thing as 4 times 4, and that is what? 16. 4 times 4, and that is what? 16. So 64 raised to power 2 over 3 is equals to what? 16. Is equals to what? 16. I believe this law number 7 is clear to us, right? I need your reaction in the chat box so we can take some application, some UTME application. All right, thanks for your response. Great. Okay, thank you. So now let's move on to applications of all these law we've discussed using some UTME question. All right, so I'm going to rub off the board. So we take app 1. App 1. We'll be treating more example using applications. All right, so let's look at the first application we have here. We're asked to simplify, open the bracket, 16 over 81, close bracket, divided by 9 over 16, close bracket, minus 1 over 2, a UTME question, 2011. All right, UTME question 2011. So let's solve this together. Follow attentively. We have 16 over 81 raised to the power of 1 over 4. Sorry, raised to the power 1 over 4. 1 over 4 divided by 9 over 16 raised to the power minus 1 over 2. Follow attentively, okay? So we won't miss any part of the explanation. Now, this is talking about the law of indices that was dealing with power in form of a raised to power 1 over x. If you can remember, that is actually what we are having here. The same thing is applicable to this one also. Okay, so let's simplify this part. 1 over 4 is the fourth root of a. Okay, the fourth root of what? A. But in this case, your a is 16 over 81. 16 over 81. So I have the fourth root of 16 over 81. So I've simplified this part. Moving on to the other side, there is a division in between them. Let's put division. Close this so that you won't mess it up. Now for this, we have two things involved. We have a minus. There's a minus here. All right? There's a minus. So if I have a raised to power minus 1 over 2, it means, law of indices, it means 1 over a raised to power 1 over 2. 1 over a raised to power 1 over 2. So if I have 2 raised to power 1 over 3, it means 1 over 2 raised to power 1 over 3. All right? Because of this minus, we have to introduce 1 over. Is that taken? So to solve this, we are just going to look for the inverse. Okay? I can take the inverse of this number, then give it the what? The square root. But let me simplify that. I will say 1 over 9 over 16, close bracket, raised to power 1 over 2. Is that taken? That's what we are having. So in a very fast way you can express it is by taking it as inverse, by saying 16 over 9. You interchange it. Your numerator and your denominator, you interchange it. Is that taken? And you give it your what? Your 1 over 2 as the what? The power. So I can say this is 16 over 9 raised to power 1 over 2. We can see that the minus is not present anymore because I've interchanged the numerator and the denominator. Okay, so let's write on. Fourth root. What was the fourth root of 16? The fourth root of 16 is what? 2. 2 times 2 times 2 times 2. That will give us what? 16. Over. What's the fourth root of 81? 81. I need the first person to give me that response. The fourth root of 81 in the chat box. The fourth root of 81. Okay, that should give us 3. 3 times 3 times 3 times 3 will give us 81. Okay, so we are done with this part. Divided by, this also means square root. Okay, this also means square root. So I'll be having square root of 16. This 1 over 2 is also square root over 9, which is 2 over 3 divided by, the square root of 16 is what? 4 over, the square root of 9 is what? 3. So we'll proceed. 2 over 3, we cannot use division like this. We need to change it to multiplication. So I will change my division to multiplication. And when I do that, I need to reciprocate 4 over 3. 4 over 3 reciprocal, we have 3 over 4. So we have 3 over 4. 3 cancel 3. Then we have 2 over 4, which is 1 over 2. So the response for that UTME question is 1 over 4. 1 over 4. I believe that is clear to everyone. All right. Okay. 1 over 4. Let's move to the next application. We'll take one more application, then give you some questions for us to evaluate ourselves briefly. So let's take app 2. I'll be cleaning the board. I believe I can rub off the board. I've received some feedback that we are good to go. Okay. App 2. App 2. Okay, let's have a question on that. Let's have a question that has to do with alphabets. We'll try to solve it quickly. If 25 raised to power 1 minus x times 5 raised to power x plus 2 divided by 1 over 125 raised to power x is equals to 625 minus 1. We are asked to find x. This is also UTME question. That is 2005 UTME 2005. 2005. Okay, so let's solve this quickly. Follow attentively. Okay, so when you look at this, the first thing that should come to your mind is that all these numbers, 25, 5, 125, 625, they are multiples of what? 5. They are all multiples of 5. So that means we are expected to make use of, 5 as the base. The least base should be 5. So I have to convert this 25 to 5 raised to power 2 is 25. Bracket 1 minus s that was there before times 5 raised to power x plus 2 divided by 1 over 25 is the same thing as 125 raised to power minus 1. So 125 is also the same thing as 5 raised to power 3 bracket minus 1, which will give us 5 raised to power minus 3, which will give us 5 raised to power minus 3. Okay, so this will give us 5 raised to power minus 3. All right, then there's an x we have outside, so let's have the x beside it. So that will be minus 3x equals to 625 is 5 raised to power 4 bracket minus 1, which is 5 raised to power minus 4. Okay, so we have 5 raised to power minus 4. Now we have to apply the rule of indices. 5 raised to power 2 times 1 is 2 minus 2 times x is 2x multiplied by 5 raised to power x plus 2 divided by 5 raised to power minus 3x equals to 5 raised to power minus 4. Law of indices, multiplication chain to addition. All right, multiplication chain to addition. So we are going to have 5 raised to power 2 minus 2x, put in a bracket, plus, I'm dealing with these two now, plus what? What was the power of this? X plus 2. All right, now to division now. Division will change to what? Minus. So I will say minus in brackets this power minus 3x, close the bracket, equals to, the response part is 5 raised to power minus 4. Okay, so the law says if the base are the same, equate the exponents, equate the power. So what we are trying to say is that we cancel out the base and we are left with 2x minus, okay, sorry, we are left with 2 minus 2x, all right, plus x plus 2, minus times minus is plus 3x equals to what we have here, 4, all right, 4. So let's proceed. Collection of like term, let those expression with x be at one side and others at the other side. So minus 2x plus x, all right, then plus 3x, okay, equals to minus 4 was here before. Taking this guy to this place, it was positive, it changed to minus 2, all right. Taking this guy also to this side, we also have minus 2. So we have this, now we have minus 2x, x plus 3x is 4x equals to minus 8, all right, minus 8. We continue here, minus 2x plus 4x. When you simplify that, you are going to get 2x. You are owing 2x, and you have 4x with you. When you pay out 2x, you still have another 2x in your own pocket, so it belongs to you. It's positive. 2x will now be equals to minus 8. Minus 8. Divide both sides by 2. Divide both sides by 2. That is x will now be equals to minus 2 over 2. Minus 8, sorry. Minus 8 over 2. Minus 8 over 2, x equals to minus 4. So the value of x is minus 4. Minus 4. And you could see that if you don't understand the law of indices, to solve questions like this will be a bit hard for us. So the basics is that we understand the law of indices and we can apply to any question we are given. So applying the rule of indices, we got our answer that x equals to minus 4. I believe that is clear to everyone. If it's clear to you, thumbs up. I want to have reactions. All right, thank you. Okay, good response. Okay, now, very quick one. I want to give us some questions to do, and they don't really need to take our time. All right, so let me start with this, that simplify 3, okay, x cubed over 3x all squared. Very fast one. Okay, raised to power 3, not square now. Yeah, 3. So I need someone to solve this for me and give me the response. Simplify this following the law of indices. I'm waiting. Simplify this expression. Simplify this expression. I wrote 3x raised to power 3 over 3x raised to power 3 here. So I want you to simplify that and tell me the final answer. Awesome. 1 over 9. Great response. Okay, great response. Let's do it together. It is 3x raised to power 3, all right? Over. This is the same thing as this power must affect what you have inside the brackets. That will be 3 raised to power 3, x raised to power 3. Of course, these two are the same. So this guy, we cancel this guy. And we have 3 over 3 raised to power 3, which is 3 over, all right, 3 raised to power 3 is 27. 3 here, 1, 3 here, 9. So the answer is 1 over 9. 1 over 9. Okay, great response, Emmanuel. Sadu, good response. Okay, so one more, but this one will be very fast. I need very fast response. Very fast response. Okay, simplify this. All right. What's the response for this question? Simplify this. Very fast response. I'm waiting. Okay, let me just carve the question out so you can see. This is what I'm asking you to do. 1. Awesome. Great response. The response is 1. The response is 1. Take note that everything was enclosed. Great response, Enoch. Great response. Everything was enclosed to be raised to the power of 0. All the expression that we have in the bracket, everything was now closed with a power of what? 0. And the law of indices states that anything raised to the power of 0 is what? 1. So you don't need to stress yourself to solve anything. So far, we have the last bracket to be raised to the power of 0. Then our answer is what? 1. Okay, that's good. I like your responses. Great response. Great response. All right. So I'm going to say this, that we still have more questions to practice on indices, and I will refer us to our A1 Tutor app. Ensure you make use of the app to solve questions on indices. Okay, just go to the CBT menu of it, click on it, and solve question that has to do with what? Indices. And if peradventure you are almost close to your responses, you can have an explanation to the correct response. Do you get that? And also, you can also get a detailed video on laws of indices on that A1 Tutor app. Check SS1 as a class. Under it, you have law of indices discussed in detail. So take your time to watch those videos and ensure that you learn smarter. Do not forget, next week again is another week for us. We continue with our live session class. Ensure you are always punctual, and also ensure you don't miss any classes. Do well to tell your friends about these live classes. Not necessarily someone that is preparing for UTME. So far, the student is in SS. Of course, everyone is welcome here to learn. We have different subjects we have been taking. And for those of us that were unable to join for some previous classes of mathematics, English, and biology, do well, and also physics, do well to check on your YouTube. Type A1 tutor, written like this, A1 tutor. Check on YouTube A1 tutor. You are going to have our videos there. A1 tutor. Sorry, written like this, A1, then tutor. So check on YouTube channel. Our videos are there for the previous classes. Do well to enjoy learning, because learning is fun actually. So go there, check for the videos for all subjects. English, we've done so many things in English. Watch them and learn smarter. Is that okay? But please do not forget, do well to subscribe, like, and share our video. Thank you for your time, and thank you so much. Can I have thumbs up? We call it a day today, and next week is another week for us to start. Thank you for your time, and see you next week.